Hello friends, today we will be disassembling and cleaning the left wheel on this Eufy RoboVac G30. Note that Eufy has left and right reversed. To them, the left wheel is the wheel that's on the left when the robot is upside down. After turning the machine off, we will start by removing 4 Phillips head screws. Remember that these wheels are spring loaded. As you can see here, all 4 screws are identical. There are no clips or anything that hold this wheel in, just the spring tension. Pushing forward slightly, then lifting up will make it easier. Alternatively, you can use like a flathead screwdriver or butter knife to pop it up. The wheel has one electrical connector and this spring that's permanently affixed to the machine that applies the downward force to the wheel. Here you can see the hook that the spring was holding onto. I always recommend not pulling on cables. Since I don't have any fingernails, I'm going to use this flathead screwdriver to take the connector out. Now that we've got the wheel assembly out, we can take a closer look at it. So this green PCB is permanently affixed to the motor. This black circle you see is some sort of encoding ring. It's likely there's just 3 magnets on it, and then on the PCB there's some sort of Hall effect sensor which senses the magnetic field, and using that it's able to measure how many rotations the wheel experiences so that it can know if the wheel is stuck and how far the machine has moved based on the wheel turning. So as I spin the encoder ring, you can see that the wheel turns. If I hold the encoder ring down, you can see that I can spin the tire on the wheel. This is because this wheel assembly is old. This is problematic as it means that the encoder ring might not accurately represent how many turns the wheel has experienced. Right here you can see the metal pin that the base plate pivots on, and then you can see where the spring goes, and that's what causes the downward force applied by the wheel. We're now going to remove these 6 Phillips head screws. These screws are all identical with each other, and they're also identical with the 4 screws that were holding the wheel assembly down. We're now going to use a flathead screwdriver to pop open the housing. Including the motor shaft, you can see here there are 5 gears. This is all one giant reduction gearbox. So the motor's a small gear, and then there's large, small, large, small, large, small, finally large, which drives the actual wheel. That's why one turn of the wheel leads to many turns of the motor. So worth noting that the motor uses a helical gear and all the other gears are spur gears, and that the motor gear uses smaller teeth. And these 3 gears in the center just slide out. The gear that's attached to the motor is likely permanently affixed with glue, and you can see the white stuff in the gearbox is all grease. It's a little bit hard to make out in the video, but the wheel is attached to this gear using a double D shaft. That's a shaft with two flat sides, and the wheel is held into the gearbox by a C-clip, which is able to freely rotate in a channel cut into the shaft. I do not own a C-clip removal tool, and unlike C-clips that are designed to be removed, which have holes or other things to aid in their removal, this C-clip has nothing. So I ended up using these two picks to pop the C-clip out. One of the big problems with its removal is it freely spins with grease. This took over 20 minutes to figure out. Here's what the C-clip looks like partially removed. This is the awkward position I had the two picks in to be able to get the C-clip out this far. This one was weaved between the shafts. The other one was just held in my left hand. This is what the C-clip looks like up close. With the C-clip removed, the only thing that's holding the wheel to the gearbox is the friction the shaft has with the one gear. So I'm going to use a flathead screwdriver to slowly pry away at that one gear. Remember to rotate the wheel as you pry so you can pull up consistently and not bend the gear. Here's what the gear looks like removed. You can see the two flat sides that mate with the double D shaft. You can see the two flat sides in the shaft a little bit clearer now, and the wheel just pulls away now. And now you can see that there's this giant hairball and what I think is like a nylon washer to reduce friction between the wheel and the gearbox. What's interesting is I thought the gearbox and the wheel met as a flat surface, but there's actually this lip on the gearbox which tries to create a seal with the wheel because it goes into the wheel slightly. Now we are going to disassemble the wheel by undoing these 4 Phillips head screws. With the screws removed, the 2 halves of the wheel will separate, allowing us to remove the outer rubber tire and access all the hair that's trapped in here. You can see the double D shaft is like permanently glued to the outer part of the wheel. Now we're going to remove the 2 screws that hold the motor into place. This is kind of unnecessary for cleaning, but I'm just doing it to show you what it looks like. I saved this step for last because I was using the motor as a handle to help me remove the C-clip. The only interesting thing is that the motor uses a helical gear. Taking a quick look at the screws that were holding the motor in, you can see that they have both blue thread locker and split washers on them, as it's very likely that they become undone due to vibration. Looking at the hole in the housing where the motor sits, we can see that there's this plastic locating tab thing. And you can see that there's 3 holes in the motor face. This is to ensure that the motor is not installed backwards, but it also helps align these screw holes for faster assembly in the factory. Now I'm going to reinstall the motor. Before putting the wheel back together, I'd like to show you something. So just looking at these spokes of this wheel, you can see that one of the spokes has a slightly longer raised part. That aligns with a notch in the other half of the wheel. And when put together, the screw holes instantly align, making for faster assembly in the factory. Reinstalling the wheel, you can see that there's a bushing, the shaft with the washer on it, which pushes through that bushing, and then the gear pushes on the shaft. I believe the orientation does not matter. And then the C-clip I will push on with a flathead screwdriver. If you're like me and you've forgotten the order of the gears, you just need to remember a couple of properties. First, remember that helical gears mesh. Those are gears with slanted teeth. Also remember that gears with larger teeth deliver more torque. So the largest tooth gear will be the last gear attached to the wheel. And you also need to remember this is a reduction gearbox, so the order in the gears will always be small, large, small, large, small, large to allow the motor to spin at maximum RPM compared to the wheel. Now I'm going to slap the gearbox cover back on and reinstall our 6 screws. We're now going to plug our motor back in. Hook the spring onto the wheel and push the wheel assembly back into place. We're now going to reinstall the 4 screws that hold the wheel assembly to the robot vacuum. After the video is made, notice the wheel now makes this weird noise. So I disassembled both wheels and swapped parts one by one to identify the cause of the issue. And I determined that it's the gear that meshes with the motor that is broken. So you can see me take it out here. And I'll put in the one from the right wheel and we'll test it together. Here's a close-up look of the damaged gear that's causing that clicking noise. So you'll see in a second there's a couple of teeth that are slightly bent. This is of course the gear with the smallest teeth in the gearbox, and this messes directly with the motor. I'm not sure if this was caused by me, but I think if it was caused by me, it would be caused by me turning the wheel with the cover on the gearbox removed, which allowed the shaft holding this gear to deflect a little bit, allowing the teeth to skip and having the motor teeth damage this gear's teeth. I tried to straighten the gear teeth using a flathead screwdriver, but it didn't work out. Here you can see, although it looks like the gear teeth are meshing perfectly with the motor, when the wheel is spun faster it makes the clicking noise. Thank you for watching. It's unfortunate I won't be able to replace that single gear, but we'll likely need to buy the whole wheel assembly if I want to fix the annoying noise.